Well, I think we're a little bit early, but you guys are so quiet. We may as well get started. Welcome to Git and GitHub for Jedi. You guys are all perfect experts. You know everything there is to know about Git, so I guess that's it. Thank you very much. Thanks for coming. No, actually, this is not a talk for Jedi. This is a talk for people who sort of know what they're doing, but they're not quite to the level of knowing everything yet. So this is tips and tricks to help you get more out of your time with Git and GitHub, and I hope you find it informative. My name is Ben Straub. This is where to find me on the internet. I come from a town called Portland. It's in Oregon on the west coast of the United States, and it is not nearly as cold there as it is here, thankfully. And I work for GitHub, home to classy PHP programmers everywhere. There are something like 350,000 PHP repositories on GitHub right now. That accounts for about 7% of our total repository count. That's a pretty big deal. It's number 6 language on the site. Pretty cool stuff. You guys have made a lot of friends there. And this talk is about tips and tricks. I'm going to spend about half my time, well, time-wise, is actually going to be more intensive on Git. I'm going to do some live demos for you. So I'm going to start with that, and then we'll move on to some GitHub stuff. So the first trick that I have to show you, apart from not being able to connect to the Wi-Fi, is called Rebase. There are several ways of taking two divergent branches of development on Git and combining them into one place. The first one, if you'll take a look at, well, it's kind of hard to see here. I'll go ahead and do this full screen. So the other thing here is sort of a live transcript of what I'm typing. And I'm going to try to keep that visible as much as I can, but for things like this, it's just not going to work. So I will be posting the transcript to a gist later on, and I'll give you the link so that you can just take a look at exactly the things that I typed, and so you can remember what's going on. So here's the history here. You can kind of see that we have a master branch. Well, this is actually not the best view. Let me do this. Unfortunately, that doesn't zoom. You're welcome. So we have two divergent branches. We have a master branch here that has a hot patch ever since the last sort of release. It's had a couple of hot patches. And then we have this extra feature over here that we've done some work on and that has become finished. So the first thing that we're going to try is the classic easy way of getting two things to meet each other in Git, and that is a merge. So I'm on the feature branch. You'll notice some magic with my command prompt here. I'm going to get to that a little bit later. I'll show you how to do that. So here, this is telling me that I'm on the my feature branch, which was that work on the new feature that's ready to go in. But like all good developers, we're going to do some integration tests before we push it out to production. So we're going to merge the master branch into this branch first before we change anything that's on master. So we're going to pull that over here. There's our commit message, and I'm just going to say that's fine. So there's our commit. And if I refresh this view here, you can see it made a merge commit. So now we have the two things all in one place. We can run our tests, and hopefully everything will be fine, and we can push it up. This is not for everybody. Sometimes you don't want these merge commits cluttering up your history. Sometimes you want your history to look more linear. Sometimes you want to do some extra things to make your commit history look prettier. So the way that you do that is, well, I'm going to get to that. First, I need to undo what I just did. So here's another couple of extra bonus tricks here. This is one of my favorite things in the entire world. This is called reflog, and it will get you out of plenty of trouble. So this shows, by default, it shows the history for the head ref. And this shows all of the places that head has pointed to since the beginning of time, since you cloned this thing. Comes in really, really handy. What I actually want is the reflog for master.
Can you pull up?
Move it up. Is that better? Yeah. Sorry, guys. Reflog for my feature. And so there's only just 2 history things here. So I'm just going to, and then the next thing is if you ever get in trouble like this, reset minus hard can be your friend. It can also be your worst enemy. Be very careful with this one. So I'm going to reset the my feature branch to where it was just before I did the merge. And if I refresh this view, we are back to, ta-da, right where we started. Very handy. Nice way to undo things. So now I want to take a look at this and actually just rewrite this history entirely. What I'm going to do is called rebasing. So I'm just going to go ahead and do that. Rebase is kind of like a merge. When you're on a branch, instead of telling it what branch you want to merge in, you tell Rebase what branch you want all of your history to be based on now. So it's going to take all of this history, it rewinds back to the master branch, and it replays. Before I refresh this view, I'm going to kind of explain to you what this did. It replays each of these commits in turn on top of master. So now if I refresh, there it is. And you actually have, these things are still left over. Notice that it didn't destroy the original commits. Those are still there. You haven't lost anything. But what it did was it made new commits that are the mirror images of what the ones were before. But they've been played, all those changes have been played on top of master, which is really handy. So now you have a nice linear history. You can do all your integration testing now, all of that stuff. Now that's pretty cool, but it gets really, really interesting when you add this flag. The -i flag, or interactive, lets you change the script that Git is going to follow. So when I do this, it pops up my favorite editor, and it tells me, here are the things that I'm going to do in order. This is the script that Git is going to play when it does the rebase. So I know for a fact that these two commits here are actually just the exact opposite of each other. One of them exactly undoes the work that the other one did. So I could just delete those. Those can just go away. And now it just seems kind of silly that I have two commits, and one of them is halfway finished, the other one's fully finished. So I'm just going to take this one and say S. You can see down below here, S means to squash. I don't know if you guys, oh, you can read that pretty well. You can actually read that better than I can. So squash means to take these two commits and just kind of mush them together. You play the two diffs on top of each other, and then you make one commit out of it. So I'm going to save that file and quit. Git's going to do those things, and then it says, well, there were two commit messages here. You need to tell me which one which one I should use. So I'm just going to use, it's no longer initial work. That wouldn't make any sense to commit here. So I'm going to delete that line, and we're just going to keep the lines that say it's done. We're going to ship it. So right quit again. Sorry, this got really large again. And I can't change it. Why are you doing this to me? So I think most of that was near the top of the screen. I hope you guys could see it okay. So now that's done. And if we go back to our history view and refresh, there. It's all been smushed down into one commit. Ta-da! Rebase. Rebase is really handy. It's a pretty cool trick. The one thing that you have to be careful of with Rebase is that don't do this with commits that other people already have, or that they might have based their work on already, because they have extra work to do to try to get their work back once you have done this and they've pulled down the changes from the server. So that's Rebase. The next trick I'm going to show you is called bisect. I don't know if you guys have ever had this situation. I know I have. But I just wrote a new test for my software, and it found a bug, like a really bad one, and like it's leaking credit cards all over the place. And that's just not good news. But unfortunately, I have all of these files, and I have all of this history. I don't even know where this thing is going to come from, right? It's a really complicated system. Where this bug is emerging from, I'm not exactly sure. So it seems like the best course of action would be to just go through the history and figure out when it was introduced. And from there, I can figure out how to fix it from the top of trunk. That's probably going to be the path of least resistance. This isn't always the case. I know this is a really contrived example, but bear with me. So Git can help you out with this, with a trick that's called bisect. And the way you do this is you do bisect start, and you tell it, basically you just tell it, I know that there's a place where this system worked just fine, and you tell it that by saying bisect good. And I'm just going to give it the initial commit, the one that's oldest in the history. So it knows that that one's good, and then the one I'm on right now, the top of master, is bad because my test failed, right? I have a test script that tells me whether it fails or not. So if I tell it that it's bad, it spits out some output and it says, oh, well, okay, I'm working on this. There's some stuff here. So what did that just do? If we look at our history here, I know we had some trouble with the projector and the colors earlier, but this seems to be working pretty well. So what it did was it actually decorated this bottom commit with a good tag. Bisect likes to decorate your history with a bunch of refs. This is so that it keeps track of where it is. It looks like it put our head right in the middle of the history. So what it's doing is it's actually doing a binary search for where the first bad commit was. So if we run our test here, all clear. So everything's fine. So we can tell Bisect that this is a good commit. And it will do it again. So if we look at our log again, it marked this one as good, and our head has been moved to up here. And it actually tells us, oh, there's probably only one step left until we find the first bad commit. So let's go ahead and run our test. And tell it things were bad. Run our test. Things are bad. And it says, ta-da, we found it. Actually, you can't see all the output here. This big, long SHA is the first bad commit. There it is. So if we take a look at this commit, we can see that, okay. Oh, yeah, okay. That makes sense. I can see where I can see the problem. I know how to fix that. That's fine. So that's great. We still have this really messy history here. But Bisect knows how to clean up after itself. So when you're all done, when you found the problem and you know what to do, you do Bisect reset. And then it shows that on my command line here, it shows that I'm back on master. If I look at my history, it's been all cleaned up. Everything's back to the way we started. So that's Bisect. But then, I mean, this is, again, a really contrived example. But what if you really did have 10 years of history here? What if you really didn't know when the problem started? What if the tests took 5 minutes instead of the 2 seconds that they take here? I have better things to do with my weekend than sit around running tests. I don't know about you guys. I'm pretty sure you do. Bisect can automate this for you. So I'm going to run this again. And since I have my script that has been specially constructed to return the right codes on a test failure or a test success, most automated unit test systems will do this for you. Like, it's already set up to be correct. So if I say git bisect bad or good 2b241, it says, do you really want to start this? Yes, I do. Good. And git bisect run. Oops. I think I may have to reset and start over. Sorry about that. And git bisect run new test. And you'll see it'll just run and run and run and run and run, and it comes up with the same answer, just like that. This can save your bacon. This can save you a lot of time. In the situation where it's useful, it's really useful. In other situations, like, don't even try this. This is probably not the right answer if you know exactly where to look. But if you're looking for your history for something, this is a pretty cool way to go. So that's bisect. My next trick to show you is something called submodules. Somebody asked about this in the beginner class yesterday. I hope to cover both what it can do and what it's not very good at. So let's see what it can do. As a project matures, a lot of times you'll find yourself in the situation where you want to take part of it and make it a separate library, or just a separate, something that's completely independent, store it in its own Git repository, and then pull it back in and keep those things kind of on different development tracks, but it periodically sync them up and make sure that they're, you get the newest version of one of your libraries, for instance. Submodule can do this. Actually, before I do this, there. So what I'm going to do is I'm going to actually add the repository where we just were as a submodule to this current one. This one doesn't have anything. There's nothing here, right? And there's actually, I think there's very, very little history. I just committed the files as they are. So I'm going to add the bisect folder as a repository, and I'm going to make a commit So now the question is, what did that do? Let's take a look at the last commit. So there's my message. Down here, it changed the .git modules folder. This looks a lot like a config file, but what it's doing is just saying, here's a URL that you're going to clone from, and here's where it goes in my repository. This is just a long-form way for Git to keep track of where submodules are and where they should go and where it should pull the commits from when it's looking for them. Down below, it also changed something. It created a file called bisect. Wait, a file? Shouldn't that be a directory? Git keeps track of these as files. Inside the repository storage, this is just another blob. But it's specially formed so that Git knows when it pulls this out in a checkout, make a folder there and note it that it's a submodule so that we can fill it in later. So there's that. And if I switch into this bisect folder here, you notice that there's actually history here. This is the same history we were looking at before. And in fact, if I recall correctly, this project had a security issue. So let's work around that. We can deal with the older version that doesn't have this problem. We just have to do without a couple of features until they figure out their credit card leakage. We don't want that. So we want to take the one right before the security issue was introduced. And this is telling me that I have a detached head. This is actually a normal situation when you're using a submodule. Usually, you won't be on the top of a branch because this is not a place to work on this project. This is a place to consume the code that this project has, right? You don't hardly ever want to be pulling in a submodule and then making commits there and pushing from there. It's usually the wrong thing to do. At least I've never run into a situation where that's the right thing to do. So now if I switch back, this is another piece of magic from my command line prompt, but you'll notice that there's this lightning bolt. That tells me that my working directory is not clean. If I check my status, it says that this thing has been modified. And if I do a diff, it shows me that it's at a different commit now. So we want to commit that. We actually want to keep that change so that everybody else has that too. Avoid security issue. Now it's clean. So that's how submodule works in general. There is a caveat here. They can be kind of tricky because of the default behavior Git has. So if I made a clone of this repository to a subdirectory inside this repository, very silly example, but I just made a clone. So I switch it into here, and I do, well, just to avoid confusion, let's take a look at the whole tree structure here. There's a folder with a file inside it, right? Which is what we expect since from what we know of that other repository. It's got all of the stuff there. If I make a fresh clone of this and switch into here and check what's there, it's an empty folder. Submodules, Git by default does not do anything with your submodules when you make a fresh clone. It just notes them, it makes directories, and they just stay empty. This is to avoid, I think, a huge network hit when you're cloning a repository for the first time, which you may not want. So what you have to do is run this command right here. That's the one. You always, always, always have to do this whenever somebody changes a submodule. And this is why they're a little bit wonky. They're not an exactly perfect feature. Because if I'm working on our project and I decide to update the unit testing library, so I update the submodule, everything works just fine, and I commit and I push, everybody else should have that, right? Well, no. Now I actually still have to send out an email to tell everybody, make sure you update your submodules. Otherwise, the unit tests will probably fail because they're using new features that aren't in the old version. It gets kind of messy. You just got to make sure that you keep track of this. It's a kind of a social issue, and partly because Git does something by default. So that is, oh yeah, and if I hit tree now, it shows the right thing. We get exactly the right stuff. So that's submodule. The next thing to look at is called filter branch. This is the chainsaw of Git history rewriting tools. This is very dangerous. Well, it's actually not dangerous, really. But you have to know how to get back once you get there. So let me show you what this does. This is a project that I cloned a while ago. I believe it's like Maven repository or something like that. Anyway, it's got a bunch of history. And if I make this text smaller, you can kind of see there's a bunch of stuff from various people. So what I'm going to do is be a little evil here. And I'm going to take credit for the first 10 commits in that list. And this is how you do that. Again, it's pretty verbose, the syntax is, but it can get a lot done in a very short amount of time, as we'll see. Now, if we look at the log, these are all mine. Mine. I'm good. This is awesome. I'm way better than I thought I was. So that's, some of this takes a little bit of insider knowledge as far as what happens when Git is making commits. Like that one, the env filter changes environment variables in between when the index is set up and when the commit is actually made. And that's sometimes, that's exactly the thing that you want. You can do a few other things with the env filter. This one is the easiest to demonstrate. There's lots of documentation on this. Feel free to look it up. I'm not going to go through it all. I'm just going to give you a couple of sort of motivating examples here. The next one I'm going to show you is the ability to remove sensitive information. So in this repository, I'm going to pretend that this pom.xml file here is just chock full of passwords or credit card numbers or something that you actually didn't want to put on GitHub, even though you just pushed this up to GitHub. You want to get rid of this stuff and push it back up right away. You got to clear this stuff out. And you don't want any of it to have ever existed in the repository ever. You can't just take this file down because somebody can just go file commits in the history and get it back, right? So what we're going to do is I'm going to run a command that filters the tree. And actually what tree filter means is that for every commit in the history, it's going to check this thing out and then run a command of my choice and then make a commit with the working directory as it exists. Pretty powerful stuff. And what I'm going to do is just remove that file. And I'm going to do it through all of history. That means not just from the head back in time, but start at all heads, all refs, and all tags, and do it to every piece of history that you can find. And that's going to take a little bit of time. The tree filter takes a little bit of extra time because it is actually writing out the working directory, just as if you were doing a checkout at every single point. And there it tells us that it rewrote every single ref in this repository. But if we take a look, we see there's no pom.xml file. I can check out 1.1.x. And there's no pom.xml file there. So it's been completely erased from all of the history everywhere. Pretty cool stuff. Let's go back to the top of the master. And then sometimes, we talked about this a little earlier, sometimes you want to take a part of a repository and actually turn it into a new repository. One way to do that is just to make a copy of that directory and just do git init and make a new initial commit. But if you want to keep the history from the files that are inside there, there's a way to do that. Filter branch gives you that ability. And this is how you spell it. It's called subdirectory filter. And I'm just going to take the source directory, just because this is a really contrived example. I'm going to take away all of the commits that don't affect any file in there and throw them away. So I'm going to create a new repository with all of the history from the files that are in that folder and none of the history from things that didn't affect it at all. So all of those commits that did not affect this will just go away. Their commit messages are going to go away. The author stuff is going to go away, all of it. And again, I'm going to pass this flag that says, do this to all of the heads in the history, not just this one. And that's going to go a little bit faster. I think it goes about twice as fast, because this isn't actually doing a checkout. So now if I list the directory, it's just the contents of what was in the source directory. So again, that one comes in handy. The 5 times in your career you're going to need it. but man, it can save you a ton of time, and it keeps all the history, which is awesome. So that's filter branch. Filter branch is a chainsaw. The next thing I want to show you is actually the cool stuff that I'm doing with my shell here. One of the things, I'll just take a look at my bash profile. So I have a couple of command line options set up here, or environment options. This top one, Git looks at this environment variable to decide whether it's going to do things with its history view. So I have this alias that does some stuff, which I'll get to in a second. But if you just do the raw log command, usually it comes out in black and white. But in my case, it's actually highlighting in yellow the SHAs of the commits. And it does this with a variety of different things. So that's a nice way to get it by default for all the just out-of-the-box commands. I'm also adding a few things to my path here, just because that's where my Git lives. And I also have this thing called gitcompletion.bash. This gives me cool things like tab completion of branch names, and tag names, and remote names, and all kinds of cool stuff. It's a big time saver. This is something that you can Google for. It's just something that's sort of out there. I forget exactly where I got mine. I don't think it came with my Git. I'm pretty sure you have to Google for it on its own. But I believe it's always called this gitcompletion.bash. There's another similar library for ZSH, if you're a ZSH person. If you're running Windows, I'll come back to that. So this works on OS X and Linux, anywhere that you're running bash or ZSH. And then down here, this again was stolen very nicely from GitHub. I get all of my cool stuff from GitHub. And this is the sexy bash prompt. It has things like the branch name here and a decoration if you if your working directory is dirty. And there's a bunch of stuff here, and I don't pretend to understand it. I'm not sure if I could have written this myself. But down here is kind of the interesting part. Here's the part where it's checking to see if the working directory is dirty. And here's the part where it's checking to see what branch you're on. And if you're not on one, it just doesn't show that part of the prompt. It's pretty cool stuff. I'm a big fan of this prompt. I don't know what I would do without it. So those are the tricks on the shell. Let's take a look at let's take a look at my Git config here. So I have the usual username and password, or not password. I'm not going to give you guys my password. I have my name and I have my email address. I also have this option set. This is another way to tell Git to use color. I think that it works in conjunction with the CLI color thing. I'm not sure which one, if one of them would work when the other one wouldn't. I'm not sure the exact details there, but I have them both turned on just because I like color. I'm a color file. And then I have this alias, which is a big, long log command, which I would not want to type 100 times. But I love the output because the standard log output is not usually what I want. Let's say it that way. But this shows me the tree of the history. It shows me in just one line. It gives me the short SHA, all of this stuff. This is almost exactly what I usually want. So I have that set up to a 2-letter alias. You can set it to 1. You can do multiple commands in aliases. Take a look. Just Google for Git aliases, and you'll turn up 100 blog posts with lots of different people who have set up aliases to do work for them. And it's super handy. Good way to automate what you do. So those are the 5 Git tricks that I have to show you. And so now I want to give you a really cheesy transition, and we're going to move on to GitHub. So some of this stuff is pretty straightforward and easy. Some of it is kind of hidden away, and I wanted to give you some of the more hidden away features that we have. So if I switch over to Safari here and see if I can log into the Wi-Fi. Nope. Oh, there we go. Yay! All right, we're back. Except that's not what I wanted. All right. Pull requests. The pull request is the single most useful feature that is on GitHub ever, or today, or probably forever in the future. This is the bread and butter for people who run open source projects, including myself. This is amazing, amazing thing. There is entire help on how to do this. If you've never used one before, I really highly recommend that you take a look at this. But this isn't just a way of like giving your code to somebody and asking them to accept it. This is a way of doing collaborative development, even inside your own team. Here's an example. This is a contribution to the Rails project. A complete stranger just sent this in. They said, here's some code. I think this would be useful for you. And the authors kind of discussed back and forth a few times. And then it was finally accepted. And it says the date. It says which commit was that accepted it. Super cool stuff. Lots of history here. There's a lot of decisions recorded here. So these are useful for figuring out why things are the way they are inside your project. But one other way that you can use this is, like this is an example where this was a commit back to Rails master from somebody else's fork. Pull requests can be sent from any branch to any branch, including within your own repository. So if you're working on one that has several collaborators, you have several people with commit access to that, you can spawn off a feature branch, do a little bit of work, send a pull request back to master. Now you can discuss things. This is inline code review. So you can do comments on the, like you can look at the diff that happened, right? And you can add comments inline in the diff. You can say, I don't really like how you did this. This isn't style guide compliant. This line is so beautiful, it makes me want to cry. You can give each other feedback. This is code review. This is collaboration. This is all of the best stuff about GitHub is right here. If you want to get some humorous ideas about how pull requests can be used, epic pull requests is a really great way to go. This top one, I read through it. I'm not going to subject you to it, but it's basically people arguing over whether spaces are better than tabs for pages and pages and pages. It's kind of awesome. There's a lot of good rhetoric being thrown around. This is one of my favorites. This is a project called DeLorean, and somebody added a pull request to add something called a flux capacitor. And you can see there was a little bit of hand wringing in review here, and then it was actually accepted. So the DeLorean has a flux capacitor now. You can all breathe a little easier at night. So pull requests, use them, know it, learn it, love it. It's awesome. The next thing I want to show you is Markdown. GitHub loves Markdown. We love Markdown. We use Markdown everywhere. We use it for our documentation. We use it everywhere that we can because Markdown is way better than writing HTML by hand. At least if you're writing prose, right? If you're making an actual site, obviously you need to write HTML. But if you're just writing prose, you're writing content, do Markdown. Every single, apart from title blocks, most places you'll see, most places where you have content to add, you can add Markdown, and there's always a cheat sheet right here. So all of these things work, including code examples and fenced code blocks. There's lots of good stuff here. But one of the things that it doesn't mention right here is the ability to add things like little graphics, little things that make your collaborators a little happier. So you can add emoji. At GitHub, we love emoji. A lot of times we'll decorate our pull requests with palm trees or shipits. And there's you can type in just about everything that there is on your emoji keyboard on your iPhone, and even there's a few things that are not available there. We have some custom emoji. So super cool stuff. Use that one to let people know when you're being sarcastic, because on the internet nobody can see you roll your eyes. So that's pretty important. Emoji, we love it. It's awesome. So I hope you do too. The next thing I'm going to show you is I have run this talk before where the whole room just went quiet when I did this. So I'm just going to type in this command and see what happens. Might take a bit. So that's a GitHub URL, and that just did a subversion checkout. Why? Somebody asked why? Partly because you can, yes. Partly for compatibility. Some people have migrated to GitHub and say their continuous integration server. They don't want to mess with that just yet, so they just change the URL for the repository, and that's it. That's all they have to do. Sometimes I've heard that this is a good way to get you This is a good way for you to get your boss to let you use GitHub, because it won't mean that the whole team has to change over to Git all at once. You can still use Subversion. This is a full-on repository. Let's see if I can get this so that it's sort of understandable here. This is a full-on Subversion checkout. You can make commits, you can update, you can push, you can do all of those things. The GitHub bridge is very smart about where you make changes on here and where you push them back to. It will translate all of these things to Git commands on the far side, and it will make new commits with your author name and everything about you. Like it looks as though, almost as though you used Git. It's pretty amazing stuff. I really have a lot of respect for the people that worked on this. I believe this is documented somewhere. There might be some more motivation for why you would use this. The biggest motivation I've ever seen is just transitional. If you want to move stuff from Subversion into Git, and if people still want to use Subversion once you're on GitHub, this works pretty well. So that's pretty cool. Here's another shell trick. This is a tool called Hub. Hub is it's a Ruby program that you can run from your command line. And the best way I've seen it used is to do this. Is that right? Yeah. So now I can do things like, so what Hub does is it adds GitHub consciousness to the Git command line tool. So instead of typing in full, and it adds a few extra commands too. Instead of typing in a full URL here, I can just do like username / repository name. And that'll open up the Twitter Iago page on GitHub. It also knows when you are, again, if you're doing a lot of cloning or remotes or things like this, this comes in really handy. It saves you a lot of typing. It also knows when you're in a GitHub repository, and as soon as if this ever finishes, I'll show you exactly what it's going to do. Come on, come on. Anyway, you can, I'll talk while this is trying to finish. You can open up issues on a GitHub repository. You can close issues. You can, I think you can open up pull requests. You can even, this ties into the GitHub API, so you can do things with this that you can't do with the web UI, like convert an issue into a pull request by attaching a branch to it. That's something you can't do with the web UI, but you can with Hub. It's pretty cool. Yeah, well. Yeah?
You can do that for your own issues, not just the person who owns the repository.
Sure, yeah. Yeah. In fact, I don't know that you, well, you could probably close an issue that you opened. I don't know that you, like I can't close an issue on Rails that I didn't open through any means whatsoever, right? But if I opened it, then I could close it. Yeah. Hub is pretty powerful, and it comes with a bunch of different stuff. There's new pull requests. Oh, you can make a fork of things. You can take a repository that exists and create it on GitHub under your username or any organization that you belong to or any kind of context you can imagine that you actually have access to. So it's a really quick and easy way to take things that are local and put them up on GitHub. Pretty cool stuff, and it adds just a little bit of help for using GitHub from the command line. So that's pretty cool. The next thing I want to show you is, this is our newest kit on the block. It's called GitHub for Windows. And I forgot to start up this virtual machine before I got here, so I apologize for the wait. We have a couple of different GitHub clients. One is for Mac, one is for Windows. They're both super handy. They do not have all of the features that a lot of other Git clients have, but they do have some features that they don't. Integration with GitHub is one of them that we've really made like a first-class citizen. This knows who I am. I've logged in. It knows about all of my repositories. I can clone them with just a single click here. Here's the ones that I have locally. Notice that it's rendering the markdown here. I can go in and view the history. I can make commits from this. It's a fairly basic Git client, but it does its job pretty well. And then it also comes with, again, if you're a Windows user, you may already use this tool, but it comes with something called PoshGit, which decorates the command line with things like I had on my bash prompt. And if I touch a file here and make it dirty, it shows that the working directory is dirty. So pretty handy. If you want this stuff on Windows, this is a good way to get it. GitHub for Windows. Love it. And then we have, there we go. I can get out of here. We have the GitHub for Mac app, which does something similar on the Mac, but again, it's just not, you don't need the, right, there's no posh Git. It's just the rest of this stuff. So they work fairly similarly. They have pretty nice integration with GitHub, so they're pretty cool. And I believe that concludes the tips and tricks portion of the talk. So there's that. Again, here's the top link here is a link to a gist where I will put the outline for this talk as well as the shell transcript that I've been recording this whole time. The bottom link, please go there and leave feedback. I'd love to hear what you guys think. And I think I have time for questions.